Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back to the podcast. I hope you're really well. I wanted to use this episode to follow up on the episode about optical activity and the plane polarized light experiment. So I want to talk through an analogy today to try and represent the parts of the experiment, as it's not necessarily something that's easy to understand when listening to just the audio version of it. So we're talking about the experiment that uses plane polarized light to see whether a sample has optical activity or not. And if you remember from the previous episode, the enantiomers, the individual isomers of an optically active compound, exhibit optical activity. They are able to turn the plane of plane polarized light from its starting plane to a different plane. Now, to do that experiment, we start with a light source, and that light has to be passed through a filter with some sophisticated parallel slits that only permit light waves with the plane aligned with those slits to pass through. So on the other side of the filter, passing further down the polarimeter, is the plane polarized light, only the light that's been allowed through. So of course the rest of the experiment is sealed off from any other light getting in. The light then passes through the sample in a sample cell and then onwards to be observed. And the observer will turn another polarizing filter to see at what angle the plane of the light is coming to the observer. And comparing that angle to the starting plane, we can see whether or not the plane of the light has been turned and whether or not, therefore, the sample is an optically active sample, an enantiomer, an optical isomer. Okay, so let's think about this analogy. And this analogy starts with, you have to imagine the scene in a busy city. It's a busy day. There are people everywhere going about their business. They're all doing their own thing, moving in their own way, in whatever direction works for them for whatever it is they want to do. And from your high viewpoint, it looks like a chaotic scene, lots of movement. So a few of those people walk into the bus station and they join a line. They get on a particular bus. And that bus sets off on a journey. It goes along a road and the road is dead straight until it reaches a roundabout or a traffic circle. And at that roundabout, there are three choices. There are three routes that the bus could continue along. So it could continue straight on, absolutely straight on. There's no change from its original course. There is a left turn and there's a right turn. And from our high viewpoint, we can observe which route the bus took from the roundabout. Okay, nice little vision there. Let's think about what these things represent. So the people in the scene are representing the individual light waves. Their disordered direction represents the plane of the naturally occurring light from the light source from where they came. And their planes, their direction, are all random to each other. The process at the bus station of joining the line and getting on a particular bus, it represents the polarizing filter. And once the bus is moving, the passengers on that bus are all travelling in one direction, and that represents them being the light waves in a particular plane, going in a particular direction. And that straight road represents that direction they're going along, and the roundabout, the traffic circle, represents the sample in the sample cell. The different directions that the bus could take represent the different things that might occur to the light that is passing through the sample. So if the bus was to go straight on, that represents that the sample is not optically active. It's not a pure enantiomer. It may be a compound that doesn't even have optical activity at all. If the bus turned left or turned right, that would identify the sample was optically active. There is one enantiomer or another enantiomer of whatever the sample compound is. So the result of whether the bus and its passengers continued straight on, past the roundabout, past the sample, or were able to turn left or turn right, represents what happened as the light passed through that sample. Was it optically active? Was the light turned to the clockwise or anti-clockwise, or not at all? Okay, hopefully that analogy helps you to visualize what's happening within the experiment to the light, from the light source right through to the observation beyond the sample. If you've got any questions or want to comment on that, I'd love to hear from you. And you can get me on Instagram at Chemistry Made Simple. I'd also love to hear if you've got another analogy that explains this as well. I always love to hear an analogy that explains a concept really well. Just want to say thank you again if you're a Patreon. I really appreciate the support that you give making this podcast possible and continue to be possible. Really appreciate that. Thank you. If you're not a patron yet, please do come to the patreon.com/chemistry made simple site and consider supporting the podcast. Really appreciate that. Other ways you could support the podcast is to share it with friends and give a 5-star rating in your podcast player. Okay, that's the end of this episode. Look forward to speaking with you again soon. Bye. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry made simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.